On July 17th, Korea Hydro and Nuclear Power, KHNP, was named the preferred bidder for constructing 2 nuclear reactors in the Czech Republic. KHNP's victory is credited to its impressive history in nuclear plant development and strong price competitiveness, standing out in the tough competition against international firms like France's EDF. Today, we'll explore the fundamental principles behind nuclear power generation, uranium fission, reactors, and K-nuclear power. Nuclear power generation relies on uranium-235 as its fuel. The reactor core, where nuclear fission takes place, contains over 200 fuel rods composed of uranium-235. Water within the core plays a dual role. It acts as a coolant, preventing the reactor from overheating, and as a moderator, regulating neutron activity to control the reactor's operation, allowing it to be turned on or off as needed. When a neutron strikes the nucleus of uranium-235, it splits into 2, releasing a tremendous amount of energy along with 2 to 3 neutrons. These neutrons, in turn, split other uranium nuclei, releasing more neutrons and causing a continuous chain reaction of nuclear fission. There are several types of reactors, including pressurized water reactors, PWR, boiling water reactors, BWR, and pressurized heavy water reactors, PHWR. Among these, the most commonly used is the pressurized water reactor, which uses light water, ordinary water, as both the coolant and moderator in the core. The interior of a reactor is mainly composed of a primary and a secondary circuit. In the primary circuit, the reactor core generates hot water through nuclear fission and sends it to a pressurizer. Normally, water boils and turns into steam when it exceeds 100 degrees Celsius. But the pressurizer applies a pressure of over 15 atmospheric pressure to maintain the water in a hot liquid state. This hot water then flows to the lower part of the steam generator. This completes the primary circuit, where it transfers heat and returns to the primary circuit. The upper part of the steam generator is filled with water from the steam turbine, which is a major part of the secondary circuit. This water is made by cooling the steam from the turbine. The water is automatically heated by the hot steam generator, turning into steam again, and it flows to the steam turbine in the secondary circuit, spinning the turbine to generate electricity. When the coil connected to the turbine rotates within the magnetic field between 2 magnets, the north and south poles, inside the generator, electricity is generated according to Faraday's law of electromagnetic induction. The core principle of a pressurized water reactor, PWR, is the separation of the upper and lower sections of the steam generator, ensuring that the coolant in the primary and secondary circuits never mix. This design safeguards against accidents, such as earthquakes, by keeping radioactive water contained within the primary circuit and the containment building, ensuring the reactor's safety even in emergency situations.